Hi, everybody. I'm Andy Chang, product manager at Google's cloud security team. And I'm joined here by Dan.
I'm Dan Hymel. I'm with Capital One, and I perform in our cloud governance and compliance space for our multi-cloud environments.
And Dan and I will be splitting the presentation duties. I'll do the beginning part. Dan will talk about Capital One's experience living this in the cloud, and then we'll wrap up.
Sure, when I start, I'm going to maybe ask you a question. Heck, I'll ask that question now. What's in your wallet? So I'll start with actually a cautionary tale. So stay tuned for that, and you're going to see a slide that you're probably not used to at Google presentations of this type. Okay? Thank you for coming.
Cool. So you're in SEC 209, shared responsibility, what this means for you as a CISO. And I think hopefully you're benefiting from some of the comfiest chairs for any of the talks, much better than the ones in the large stage area. So, as since you've been through a few of these sessions, we're also taking questions in the dory. And so go to your app. If you have questions that come up as we're talking, please enter those in, and we'll handle them towards the end. We'll be covering a few things. The overall, one of the questions that I get talking to customers is, what is the exact split on the shared responsibility model? How do I understand it? How do I leverage that? How do I make sure that the cloud provider is doing what they're supposed to do and that my own company is doing what we're supposed to do? So we're going to talk a little bit about the perceptions of what customers care about in security, the understanding that shared responsibility division, focusing on visibility and control, and then ultimately focusing on a quick architecture example. Then I'll turn it over to Dan to kind of talk you through the lived experience at Capital One, how they've been successful on multiple public clouds, and then we'll wrap up with questions and answers. So when customers talk to me, the things I hear that folks care about are really that the right data is delivered to the right customer at the right point in time for the right purpose each and every time. And that's some of the core of security. The right thing and only the right thing happens when it's supposed to happen. In addition, given as we all see the current threat environment and the activity of threat actors increasing, it's important not just to react well to situations, but also to be able to anticipate and innovate ahead of through these threats. In addition, many of you are in regulated environments, so it's important partner to be able to essentially enable you to deliver on your responsibilities while running your businesses in the public cloud. And lastly, and really the focus of this, is understanding and having a clear understanding of the responsibility model. I think we're going to switch over to guys here. Okay, so now we're. I think this is still.
Sorry, folks. Give us 1 second to get this straightened out.
Okay, so I guess we're on the head mic.
Yeah, try the head mic.
All right, I don't think we're projecting still. Okay. All right. So this is better. Cool. All right. So we're going to talk about. I think it's still cutting in and out. Technical difficulties. Cool. All right. Can you guys hear me? Okay. All right, we're going to go with the hand mic and see how this goes. Thank you. So we're going to, the focus of this talk is really on the understanding, enabling you guys to understand where that split is from a shared responsibility standpoint. And really, ultimately, for you as CISOs, as you as folks part of the security part of the organization, enabling you to actually accelerate your company's business velocity with enabling your stakeholders to have and understand really what is the controllable and acceptable amount of risk. So really focusing on this area. At Google, the way we think about the shared responsibility model is really around two key items: security of the cloud and security in the cloud. And we'll talk about how we divvy those things up in a moment. From a core principle standpoint, security at Google is done defense in depth. We have at least 2 layers of protections that are independent from each other between anything of interest, anything you want to protect, and any kind of bad activity or threat actor. At scale, so as you can imagine, Google, I think other folks have said we're 25% plus of the internet from a traffic standpoint. Things done at Google for security or for other things have to be done fully at scale and work at scale. And by default, right? How do we enable our developers, how do we enable the system so that the controls that are necessary and required are enabled by default so that folks can run? At the core underlying this is really the use of strong cryptographic credentials and identity. And what that means is that whether it's a machine, whether it's a human, whether it's the data, whether it's the code, whether it's the underlying service, they all have unique cryptographic identities that we can compare against what should be happening. And provenance, the ability to establish through a hardware root of trust that the underlying hardware, the low-level software, the OS software, the applications that are running are all fully attested to at each stage, and that we're running the right code at the right time. The other part of this is that, at Google, we think trust isn't gained just through technology, but also through transparency. And really what that means to you and to customers in general is thinking about reducing what we call the unverifiable trust surface. What that means is minimizing the amount you actually have to trust us as a cloud provider, having you being provided enough information that you can make a decision of your own to verify the claims that we're making. And that's a core part of what we're trying to do. Ultimately, we're interested in providing customers the capabilities to help you build secure applications and fulfill your part of the shared responsibility model. When we think about the controls that are in place, we really think about them in 3 kind of areas. Underlying control, things that really help you protect the data. Visibility, the ability to classify the data and monitor the actions on that data. And then detection response, the ability to actually validate the controls running and detect essentially things that are non-compliant activities that could be threats or from bad actors. And for each of these areas, we have technology that we provide to enable that. When we think about the shared responsibility model, it's important to understand that the boundaries of that shared responsibility vary based on which types of services you're using. And for many of our customers, they're using a spectrum of services, which is why it's not surprising that as a CISO or as a part of the security team, the details of for what service and which part can add to additional complexity. And so it's important to understand where those divisions are. When you're running on-premise, everything in the blue represents the customer. So when you're running on-premise, you own all of your hardware stack, your relationships, the underlying software running. So not surprisingly, the full responsibility is really on you as the customer. When you're running as an infrastructure as a service, which is essentially running your own virtual machines on our platform, but installing your own images, setting up your own network architectures, the responsibility for us is to provide you the ability to log and audit the things that are running on the system, the network, the underlying hardware and infrastructure, the pieces that you're building on top of, so that the services we provide to you are secure, and then you're responsible for putting those things together in secure architectures. When you're running a platform as a service like BigQuery or App Engine, one of those things, now really you're providing us code that you're running, and we're responsible for delivering the underlying services that execute that code in a safe and secure way. And when you're using software that we've provided, now we're responsible as well for the code. So if you're using Gmail or Drive or Docs, that code has then become part of our responsibility. And then the thing that you focus on is access to those applications, access to the data that you provide, and then the data that you're loading into those applications. That's kind of a quick summary of the different levels, and we'll go into some of this in more detail. So as we talked about from a Google perspective, we think about security of the cloud and in the cloud. Of the cloud is the core, about the core infrastructure that you're then using and the core services to build your products and applications for your consumers. For Google, we're responsible for security of the cloud, and we think about it as, again, defense in depth at scale by default. We model kind of the underlying architecture that you're running on top of in 9 layers. Everything from the hardware all the way through the underlying low-level software, the applications, and then ultimately to usage. And everything that we do at Google is rooted in a hardware root of trust, which is the Titan chip that you've heard of through the last couple kind of Next conferences. It's a purpose-built chip that we've built, and it sits on our compute cards, our processor cards, and establishes on boot a cryptographic identity for that piece of hardware and verifies that all the underlying pieces of software that are meant to boot are doing so in the right way, that the hardware components are correct and configured the right way. And if any of those things fail, that card or that compute instance does not actually boot and be entered into the fleet. And that allows us to make sure once something goes through that it's in a known good state and it can be put into the rest of the fleet and start serving customers. And that becomes the underlying piece that drives our servers, our storage, our network, and then ultimately our data centers. And what that allows us to do then is reduce the threat for folks injecting either malicious hardware or malicious software into our systems. In combination with that, as we talked about in the beginning, it's important for us at Google that we have the ability for the code that we write to define that the right identity accesses the right machine, is authorized by the right code, accessing the right data, and it's in the right time and context. And that's done through cryptographically secure identities. So not only users have identities, machines and services have identities, devices have identities, and then code and data have identities. And checking all of those things when we run a Google service is a core part of our underlying platform. Here's a stack, a little more detail, of the different pieces within Google that come into play to secure each layer. And you'll see that there's at least 2 items at each layer that are put together to provide redundancy and really defense in depth. Whether it's the purpose-built underlying infrastructure or the fact that we, from a boot standpoint, cryptographically sign all the pieces of our boot software. From an operating system and hypervisor standpoint, we use our own version of KVM, where we stripped out a lot of parts of the virtual machine monitor, reduced its attack surface and its risk surface. We've also then added sandboxing in, so that further creates a level of isolation. From an OS standpoint, we use our own curated operating system for our host side. We also make that available as the container optimized OS for you as a customer to use. If you're using our container optimized OS, you can also enable automatic updates, which will patch the container optimized OS, so you can leverage and benefit from the same type of security controls we have when we run on our host side. From a storage and network standpoint, unique to cloud providers, all services, all data is encrypted at rest and in transit at Google. The logging of kind of both internal Googler access as well as providing audit logs for your users and your systems and what they do in your systems. An identity access management system that allows us to do fine-grained permissions, and then really managing those keys that are core part of encryption at scale. From a networking side, we have one of the world's largest private networks. What that means is that from when your data or your service is touched by a customer from outside our network, it basically travels wholly on Google-owned private networking, private fiber to the server in our systems. And that gives you not only performance advantages, but gives you a single threat to choke from a network security standpoint. There are no additional actors in the underlying hops. From an application standpoint, both from the whole software lifecycle, from static analysis to the patching and checking of the packages that are loaded in, we have control over that. We also cryptographically sign each piece of software as it goes through the development stage, and then check before it's deployed that the manifest has all the right policies applied. That's something we've externalized to customers as a part of binary authorization. So if you want to adopt that same model, that you can run vulnerability checks, various types of patching checks, static code analysis, and then as long as code passes that, create a cryptographic signature and have that checked before the code is deployed, you're able to do that through our binary authorization product. Once the applications are up and running, they're protected by our own global front end and the WAF capabilities and DDoS capabilities around that. And then we provide as well our own security scanning for L7 web application vulnerabilities that we use inside of Google as a product called Cloud Security Scanner for you to use as a customer. When things are deployed at scale, we're very fond of saying that your first users are typically abusers. So whenever we deploy a service, we see a lot of attack traffic. Therefore, the built-in DDoS for our own services, the ability to be our own CA. So it's very hard for folks to forge anything related to kind of connecting to Google, and that all services provided at Google are at full TLS. Finally, from an operations standpoint, not just trusting us, but having third parties do compliance checking, the ability to do live migration, which enables us to do patching of live running VMs without taking your services down, allows us to, on a continuous basis, do that level of patching and keeping things up at the highest level of security. And then we have full SOC, threat analysis, and the ability from a user standpoint to connect to our services through Beyond Corp, a zero trust type network, as well as for them to do hardware-based second factor for security key. And that is the structure for every service created at Google and used at Google, and the tools in which you would then build on top of when you use one of our services. When we think about enabling customers, we do this providing the same type of set of services, either in the dark green as products you can consume, in the light green as either products that you can use from Google or that you can get from partners, or in the case of the dark blue, core things we still do by default for you when you're running on Google Cloud Platform. We're going to talk and highlight some of the key differentiators on Google Cloud Platform that will help you do your job better and fulfill your part of the shared responsibility from a visibility and control side. So one of the core things which we announced to general availability this morning is the Cloud Security Command Center. That's that central pane of glass that you can bring in detections from Google native products, third-party products, or ones you've written yourself for vulnerabilities and threats all in one place, and see those in context with your assets and the business context of those services and the sensitivity of the data. Gives you one place to look for visibility, one thing for you to then query, understand your data, and then the ability to trigger prevention, detection, and action. In addition, what we feel is a key part of the understanding the attack surface is understanding where your data is and what sensitivity level that is done. What we provide is the same service we use within Google for data classification, our Cloud DLP API, which is designed to work at data at exabyte and petabyte scales, which allows you then to, number one, for data sitting in Google Cloud Storage or data sitting in BigQuery tables, to classify at scale sensitive data, either through our built-in classifiers, the ability to use regular expressions, or to express this in terms of data sets that we can train our models on. Once you've identified that data, you would then have the choice of multiple de-identification options, simple things like substitution encryption, more intricate things like format preserving encryption, or transformations that allow the data still to be usable in analytics, but in parallel preserve privacy. In addition, unique to Google is we provide access transparency, which means that we provide you in our audit logs notice every time a Googler accesses your data, and for what reason that Googler was from, and the case number in the case of customer-initiated support events that triggered that access. This is across the wide range of Google services, and unlike some of the other providers, not just restricted to a small set of the provided services. Also, at Next, we're very excited to announce access approvals, which now allows you to prevent Googlers from accessing the data in real time for a subset of the data. So not only will we notify you if a Googler is trying to access data, you can actually get the ability to say you will not allow that and grant that access, and the Googler will no longer have access to that data and will not start having access to that data. The results of these are surfaced in Cloud Security Command Center, also through the audit logging APIs. One of the key parts we talked about earlier was trust through transparency. And so part of that is there's a lot of things that we've told you about our technology and how we do things, but you don't have to just trust us. We go through twice a year set of certifications. You'll see some of these here, and that those certifications go on an ongoing basis. Working with your sales teams and with your account teams, you can get access to some of the reports of these things so you can see for yourself that whether it's overall global standards or country-specific standards, how we do against the requirements and certifications you need to run your businesses. When we move to control, one of the key things that's unique to Google is an emphasis on providing out-of-the-box, top-down, logically central, but globally distributed controls. We were the first of the cloud providers to provide organization-level viewpoint, a top-down resource hierarchy that also is an IAM boundary and also is a network boundary, so that you have the ability to start your systems and your developers in a safe mode where they have, by design, restricted access that you then can explicitly only grant through the IAM roles. From an IAM standpoint, we have over 300 curated roles. So out of the box, the separation of duties are built in by those products, requiring explicitly grants for folks to use that. We have hierarchy and inheritance in our resource hierarchy. So if you're given something at a folder level, that person then can have the underlying roles in each of the projects below that. But if you're at a project level, you can't go up the chain unless you're explicitly granted that type of access. In addition, we have org policies that you can define at the top level that can be enforced across all your organization regardless of the underlying pieces. And then we're going to talk about two other things that affect your communication pattern. VPC service controls, which provide you the ability to define service perimeters. So unlike the traditional L3, L4 networks, which are based on routes and IPs and restrictions based on IPs, as you move to microservices, services then have unique identities, and you have the ability to block services access to particular types of sensitive data or projects, and those can be applied to Google services as well, so that you can block, for example, Google storage writes or reads from a particular set of resources only unless that those services have either belong to a particular access level or have a particular set of permission groups. In addition, we also provide a similar set of capabilities around your L3, L4 level networking. So we have the ability for you to create what's called a shared VPC, and in that shared VPC, define all the firewall rules that apply to all the tenant VPCs. So you have, again, one logical choke point where you can provide the administration of your overall network and separate and independent from the underlying administrators of the underlying projects. Both of these concepts are designed to provide you logical bottlenecks and choke points for control, but not cost you anything on the performance side, because they're implemented in globally distributed ways. And those are unique to Google. So VPC service controls, as I talked about, is really defining service level perimeters, which allow you to put that around specific sets of sensitive data, allow you to define access levels, and those access levels allow you to put policy requirements, for example, of what kind of geographies that the data can be accessed from, what kind of restricted IPs, what additional device characteristics are needed to access that data. Those access context levels apply not only to infrastructure controls like this, but also back into your G Suite, access to docs and Gmail. So in one construct, access levels, you can define a set of controls that apply across both G Suite and GCP. Similarly, from a key management standpoint, as I talked about, by default, your data is encrypted at rest and in transit. But we know from some of our customers, they have additional either regulatory requirements or views of their threat model or risk that require greater control of their keys. So we provide a full spectrum. From the left, default encryption, you don't have to do anything. Your data is encrypted at rest. Cloud key management system, which allows you full control of creation of keys, destruction of keys, rotation times and periods, full logging, IAM roles on those keys, so you can demonstrate to your regulators and auditors that you have full control of the keys. Cloud HSM, which is a hardware-backed solution so that you can have the root of trust for those KMS keys be in hardware, and it's a FIPS level 3 hardware, globally distributed cloud HSM system. You can also, if you need to have the root keys be sourced within your own org, you can use cloud, essentially, customer-supplied encryption keys, which allows you to push the encryption keys to us when you need something decrypted, We do not store that key. It stays only in memory for the live operation, and therefore you have not only the root of trust in your own hardware system, and we have no access to those underlying keys. You can also have essentially the ability to stack HSMs, your own HSMs in our colos if you want that further level additional control on essentially customer supplied encryption keys. So depending on the risk parameters of your business, you have a full spectrum of capabilities available to support data encryption. And before I turn it over to Dan, I'm going to talk through now how the various controls get put together when you think about a secure architecture. So first, most customers start with a clean slate. They have an existing on-premise or other cloud installation. They have identity set up, typically not a Google identity out of the box from an enterprise standpoint, local compute, gateways, and then data. So the first thing to do is to essentially connect to Cloud Identity, which lets us federate your existing identity service, and now brings those identities to be used in Google Cloud Platform. Then, through the groups and the underlying individuals, assign out the IAM roles and policies that you want so that folks have the correct separation of duties. The ability to establish upfront org-level policies that apply regardless of the underlying pieces across your whole organization. For example, that VMs cannot have publicly facing internet addresses. Then the ability to define, again, from a L3, L4 level, an overall control of your firewall rules and networking through shared VPCs. Breaking out from an HA standpoint and a disaster recovery standpoint, the various regional pieces you want to allocate within each of the regions, the zones, the resource allocation, and then the underlying subnet connections. By default, and unique to Google, our networks are global by default. So you're able to make those connections very straightforward. You don't have to pair between the different regions. Our VPCs are global by nature, and you're able to therefore set up HA and DR in a very straightforward way. Next thing you want to do ultimately is you have data sitting in your on-prem, and you want to bring it securely into GCP, or take the data that we compute and bring it back to your on-prem. So combining cloud router, firewall rules, dedicated secure interconnect, either through our own peering or through partner peering, allows you to bring the data in and out of your area securely. Also, we have VPNs to allow you to do that as well. Next piece then is, from an application standpoint, protect your application once you serve it from the typical attacks like DDoS. So you can either use our default global load balancer, which, as long as you put that in front of one of your GCE services, will take advantage of our global front end. You can use one of our managed services, which has DDoS built in, or you can use the Cloud Armor product, which gives you additional availability and the ability to write your own rules to fine-grain manage your DDoS and WAF. Next piece then is you want to turn on logging so that you have the monitoring and evidence of things that might happen to allow us to do detections. And audit logs are turned on by default. You can then also look at VPC flow logs, firewall logs, and then general logging. Then you want to turn on the monitoring, learning, and detection pieces, which include the Cloud Security Command Center, security health analytics, the ability to look at stack driver monitoring, running security scanner on your essentially web applications, and then if you want to dump the data into BigQuery for additional processing. You then create a service project, which allows you to kind of create that boundary of control for the services you want to run, and then create kind of a secure perimeter using VP service controls around that so that you can restrict which services can access that underlying data, and then ultimately bring those data back through into GCP through either private access, cloud DNS, and cloud natting. So you can either replace your kind of subnets into GCP or push our subnet pieces out. So in summary, those are kind of the steps that you take to pull things in and are the building blocks of you building a secure service on GCP, and some of the pieces we give you to fulfill your part of the shared responsibility model. So with that, I'm going to turn it over to Dan to talk to you about Capital One's journey.
Great. Thank you. Are we using this mic?
You can, no, we can use your mic for this.
Okay, great. Andy, thank you for opening the stage and allowing me to present and open the windows on what's actually going on inside of Capital One. So I promised you a cautionary tale, And this little creature's name is Altria. Altria is a rescue dog that my 12-year-old daughter picked up from the Richmond Animal League in Richmond, Virginia. What does this dog have anything to do with the topic of shared responsibilities, compliance, and controls? On the cover, probably absolutely nothing. But take a closer look. Take a look at what's around her neck. So here's the tail. It happened shortly after Google 18. About a week after Google 18, this little dog, Altria, love her to death. She has no malicious intent whatsoever, but she's a runner. She was trained as a hunting dog. She's an American hound. So on one particular night, this is probably after the 5th escape from the homestead. We live on a parcel out in the country. We kept talking about, let's put in a security fence, an invisible fence. And we kept holding off because the price was too high. So on one particular event, she left around 8 p.m. She has free run of the neighborhood. We live in this river canyon on the James River where about a mile on either side there are no fences, and you can run from the Chesapeake Bay all the way to the mountains. On this particular day, it was about 11 p.m. at night. We were exhausted. We couldn't find her. We came home, and as I was planning to go around the house to check things out, I felt this immense pain in my leg, and I jumped and wondered what the heck happened. So I looked down, and on the corner of the eye, there was a copperhead snake. Unfortunately, that snake took advantage of the opportunity, and as you know, later that day I was in the paramedics box. I was at the hospital. I was being treated for a copperhead snake bite. So as you know, in everyday life there are risk scenarios everywhere. This is a very good example. Had we actually put in the security fence, we would have avoided Altria from escaping from our private domain out into the public. So as a result, we implemented this control. It's a shock collar. So as you approach the fence, she gets a really enlightening experience. If she's able to go beyond that barrier into the public domain, there are some other controls that we've implemented. So what you might not know about the rescue dogs is that when you receive them with a chip. So if they are captured in public, there's a way to identify those. We also added a collar or a tag. The tag used to have only our home phone number, but she runs so much that we actually had to put a cell phone number because we would get phone calls at home when we're actually out in the field looking for her. So as you see now, it has a lot to do with cloud controls, with controls, with shared responsibilities. It's the whole community. So let me take you into the Capital One journey. I'm going to open the window for you for a moment. You won't see this often, and I'm going to tell you and share with you a few nuggets on how we made our journey into the cloud successful. So Capital One today has a significant need for cloud because it enables us to operate with the speed and agility required to succeed in the digital age. Our agile sprint teams work in 2-week cycles, and according to them, infrastructure must not be an impediment. As a result of the moving to the cloud, there are some stats, and these are real numbers. We've moved from a development environment build time of 3 months down to 30 minutes. New product features, which used to take a month, now take 2 days. With unparalleled visibility into our environments, we have an overall improved security posture. I'm going to talk back on security in just a moment. Our current cloud status is this. We have over 8,000 production applications and services. 6,000 additional services and applications are in non-production, and nearly 100% of our production and development and test servers are in the cloud. Additionally, moving to the cloud has increased our ability to secure and manage massive volumes of data, of high-quality data, operating at a higher speed with greater resiliency, faster recovery, and at an extraordinarily lower cost. With cloud, our technology organization is free to do what we do best, build digital breakthrough experiences for our customer. If you are a customer of Capital One, feel comfortable in knowing that we have your back and we're doing our very best using state-of-the-art technologies and best practices to protect your sensitive data. To make this happen, to make the security posture happen, we've implemented a methodology around controls and compliance. A lot of organizations might call this cloud governance or a governance function. So essentially that's what it is. It's an enterprise function at Capital One that balances the need of compliance of cloud controls, objectives, and the needs of various stakeholders, from our board of directors to executive management to the enterprise communities like operations engineering, info security, and cyber, all of the communities that come together to help enable our security capabilities in the cloud. And most importantly, then, our divisional customers. These are our lines of business, our banking community, our auto finance community, our card community. These are the application builders and consumers of cloud services. Another way to look at cloud control and compliance is it's the totality set of policies and procedures that help an enterprise move towards its goals while minimizing risk and conflicts. So for us, our journey here, our goal is all in on the cloud. And that's just about where we are. So let's go back to then, what is this cloud compliance function? What I'm going to share with you is a best practice example that is aligned very closely with the Cloud Security Alliance methodology. So think of this as a box of cake mix where you flip that box on the backside and it gives you all the ingredients. These are all the ingredients to make it happen. These are the best practices. You have to include all of these, in my opinion, in your program for cloud compliance to have the maximum benefit to ensure that you're doing the appropriate level of due diligence for your environment. I'll go by these one by one, and then I'll give you some more detail on what they actually mean. So first off, you must document and maintain a catalog of control objectives. These objectives are partially derived from NIST 800-53 or FedRAMP Moderate. They are also a compilation or a derivative of your internal security policies and procedures. Secondly, for every single service that our cloud providers offer, we perform a security control assessment using a selected set of security control objectives in that catalog. And for now, our current state is for our catalog of about 300 control objectives, we use about 50 of those that are directly applicable to cloud as it relates to our shared responsibilities. And of those 50, 15 of the control objectives are mandatory requirements, meaning that if the service provider, Google, provides a service to us and it doesn't meet any of the 15, that's a showstopper. So we'll just tell Google, we're not ready yet, we need some more features before it's safe for us to consume that service. Next, once you've done the risk and the security assessments, you move into the phase of performing the risk analysis on the gaps that you've identified relative to your control objectives. So depending on which industry that you're in, you may have a different set of objectives than what Capital One has as a financial service provider. Today we're using a composition of qualitative and quantitative methodologies. We're looking very closely at probabilistic risk analysis, which means that there's a probability in a risk scenario of an event happening over an annualized time period causing a loss of money in a particular range. So now that you've identified your gaps, now it becomes the tough part. This is a continuous process on risk management, control implementation, control compliance, control exception processing. You have to implement your controls, you have to monitor your controls for compliance, and you have to allow application owners to make exceptions against using the services that might not have all the controls or for which you're not able to meet all of those. Not a requirement, but the next one is the divisional governance advisor, and what we've done is we've assigned a technical subject matter expert like myself to support a particular line of business that translates everything that we've talked about into terms that they consume, and most importantly as well, training. That the associates that perform in this function need to have background as a subject matter expert in the cloud provided environment. Back to shared responsibilities component of this. Andy talked ad nauseum about this. This is really great. So I won't go into any detail here, but I wanted to share with you that we understand this well, and I'll just move on to the next one, which is a payout slide. This slide basically says for Capital One, we look at shared responsibilities from both a platform perspective and an application perspective. Let's take the application perspective first. I'm sorry, the platform perspective. So my team working in cloud governance, we do everything that we talked about before. We assess the services, we ensure that they meet our security requirements. We work with cloud engineering teams, and we provision the services and make those available to our consumers that leverage those services by way of applications. So we're accountable for then assuring that we implement platform identity and access management, that we deploy the operating systems appropriately, meaning that we provision system images rather than using the cloud provider images. We provision our own so that we appropriately harden them to meet our internal standards. We're accountable for what we put into the cloud. So we take full responsibility for that. One particular example of a control related to this is a notion of rehydration. So as a virtual machine ages, it takes on vulnerabilities because of the vulnerability aging process, and so we have a requirement to rehydrate every 60 days. If you go beyond that, bells and whistles go off. If you go past 90, bigger whistles go off. If you go to 120, the cannons go off, and so forth. So I think you get that. So our cloud governance function from a centralized perspective is we make controls and scripts available that either we can run on behalf of the development community or that we can give it to them and they can actually run it. For example, there might be a requirement to apply labels or tags to all of your resources. If the development community forgets to do that, they can run a script to make sure that they're compliant to that. Let's move on then to the application. If you build it, you own it. That's the mantra at Capital One. So if we offer a service to you, you're golden. You can use that. It's been whitelisted. The controls are in place, but you have some accountability. I'll talk a bit more about that accountability. So why are cloud controls important? I wanted to make sure that you had full visibility to that. For Capital One, it's our mission and our fiduciary responsibility. If you take a standard document classification or information handling matrix, you will find that your proprietary or confidential data is probably your most important asset and requires a level of protection beyond those that are company or public. So what we do and how we've bifurcated this is we look at the controls in the Cloud Control Catalog in three particular areas: as technical, operational, and management. And I'll show you on the next slide how we codify those. But most importantly, the controls have to always be on. The windows have to always be locked. So that means security protocols, public accessibility, data encryption, identity access, and PCI. There is no opportunity, there is no tolerance for control being off. So where do cloud controls originate? I mentioned to you a bit earlier that they might originate from cybersecurity frameworks, NIST, FedRAMP, and so forth. Here's a particular small matrix of the 14 control categories in the NIST framework, where I've bifurcated those by technical, operational, and management. So we take our cloud control catalogs, we look at a service that Google has provided, we perform that security assessment. The diagram below, or the colorful green, red, blue chart, is the actual detail of the questions that we might ask. And incidentally, I have to say that Google has been an extraordinary partner in this. Google has our scripts. They know what we require. They know when a service is ready to meet the higher bar for financial services industry. And so they are embracing that. They're working very diligently to say, hey, Capital One, we've got this new service, and they know what our requirements are. So they know when to actually make the ask. And finally, we complete the service assessment. We deliver the package. Now, it's important to note here under item C that it's a cross-functional team. We include governance, we include engineering resources, cyber resources, architecture, IAM architecture, and also our our information assurance third-party management function, where we fully validate. We have an auditable trail that our regulators and our internal auditors can go back and say, did you ask that question? Google tells a lot of good things about their services, but we firmly believe in trust but verify. So this is the final slide. I've got about 15 seconds or so, and then we'll save time for Q&A. But here's the payout, and this is what resonates with shared responsibilities from an application owner perspective. Here's what it means. If you have an application, let's take a basic multi-tier architecture application, where you're going to need a load balancer, a web server, application server, database, and file storage. That application, or the type of application, may require that you adhere to an enterprise architecture standard. There may be a defined architecture already. The architecture might even say, in order to meet the requirements for the architecture, there are certain cloud services that you are mandated to follow. So the application owner defines the application, they choose the architecture, they select the cloud services that are approved. This is by no means the only list of what's approved at Capital One, so we could put ... After you select the approved services, then you become more aware of an application owner of what your actual requirements for controls are. So if you pick a compute engine, if you pick storage, you will have some requirements for identity access, data encryption, and so forth. So this is really the whole story. There's so much detail here. Feel free to reach out to me on LinkedIn if you have some follow-up questions, and we'll actually go to back to Andy to close it out for us.
Thank you, Dan. So kind of in summary, though one last slide. So security of the cloud is something the cloud provider secures. Security in the cloud is something that the cloud customer secures for their data and their content. Google Cloud, we look to empower you as a customer with the visibility to control and secure the things that you're responsible for. And as Dan talked about, customers can be successful in cloud using a very thoughtful process, structure, and clean separations responsibility within their own org.